my lab 4 for physics 2 and the lab 4 circuits. The purpose of this lab is to predict the behavior of circuits with resistors in series and parallel, use multimeters to measure the actual values of conventional current and potential differences in circuits, and to examine the behavior of ohmic resistors and capacitors. The initial values of the system were system is the circuit and surroundings is everything else. And then the results, simulated circuits behave like idealized circuits. Key ideas and equations, energy conservation, so the loop rule, which is right here, Ohm's law, which is this one right here, current conservation, which is charge conservation, steady state, which is right here. And we use these to calculate different values, given the values given by the voltmeter and ammeter in the next slides you'll see. So first experiment, do the ammeter configuration. Before I set up the circuit, predicted that it was going to be 0.02, and then R1, R2 were these values. And then with the ammeter replaced by a voltmeter, which there's a picture on the next one, but that is this right here, where the current is 0.02 again, and delta V is, or the change in energy potential is 3 amperes. Or amperes. And then with the closed circuit, we have all this, but you'll see that in the next as well. The closed circuit right here, we can see where the voltmeter is, and these little prongs were moved to different places on the circuit to see how each component affected the voltage in the circuit. So you can see delta V, the batteries, if you placed it on either side, it was 3 volts. And then after it passes through this first resistor, which was 47 ohms, the voltage was less after it came out by 0.96, and then same with after passing through 100, it was less by 2.04 volts. And the sum of delta V was 0 because of loop rule. And then this shows that is 0 basically, because of said loop rule. Then we see our potential versus position graphs. This was the section that was given, and this was after passing through the 47 mark. Which this should be a little bit higher up. Sorry, I didn't make that really to scale, but because this decreases the potential in the circuit, or it decreases the voltage. And then in the little stretch of wire between the two resistors, it remains stable. And then after it passes through the 100 ohm resistor, it decreases more sharply. And then while it's going through the ammeter, there's no change because there's no more voltage. And then, oops, sorry. And the additional questions that were asked in the document, the ammeter reading does not change with an additional voltmeter because the voltmeter doesn't allow a lot of current to flow through, so it's high resistance and does not change the reading. And then if the ammeter is connected in parallel with the 100 ohm resistor, both ammeters will show 0.06 amperes. And then for the circuit's element resistance, we calculate that using the previous equation, which was, sorry, right here, Ohm's law, and we use that right here to find how many ohms the resistor used, which was true. This is the right answers, and then this as well. These are the resistances, which would make sense because the wire and the ammeter should not have much resistance, while the resistors should have the amount assigned to them. It's just checking. Then the circuit that we did in lab, and then the simulated one that I did to make sure the data was correct, because we really struggled getting this to work. Equipment was 9-volt battery, 200. Well, you can read all the equipment. As a capacitor gets charged, the lights dim because the charge collects on the capacitor. And then when the battery connects to the 10 ohm bulb, capacitor is charging, the current in the circuit decreases. And then this is the time for the capacitor charge using both of these light bulbs. And we only had one in lab, so I also had to test it over here. That's noted down below. And then this was to discharge when we removed the battery, the charge from the capacitor reverse direction, and the light bulb lit up, and then it slowly dimmed because of that. And then the new circuit, this is the plot we found, and this is all the data we predicted. That's all of that. And then some of the error, human error in taking calculations from the actual circuit because we struggled a lot getting it to be stable because the light bulbs kept blowing out. And then using a mix of both predicted numbers from the PhET simulations and the real life circuits also probably caused some error for me. Discussion, because I used both real and simulated results, you can see that the real results were lower than the simulated ones, and then the capacitor would not have charged to its full capacity as quickly because internal resistance would have stopped it at an earlier point. And that is the end.